Hey everyone, welcome back to the channel. So before continue with the MLOps playlist, I want quickly cover something that extremely important for the upcoming modules, object-oriented programming in Python. I have already shared a lot of videos on Flask, MLflow, AWS and end-to-end MLOps setup, but as we go deeper into production level projects, you will see that OOP becomes a must-have skill. Whether it's building reusable pipelines, modular coding, or clean architectures, or scalable ML systems. That's why this OOP video is added inside this MLOps playlist. It will give you the exact foundation you need for the next projects in this series. So alright guys, let's jump in. So let's start with the definition of object-oriented programming. Again guys, this definition you no need to keep in your mind, but just I'm reading out for your information. Object-oriented programming is a way of writing software where we build programs using objects. What is object and all we discuss. Just like real world things, each object carries its own data. So there can be some object that will carry its own data, its own behavior, and we create them from blueprints called classes. So there are some concepts, classes and objects in OOP in Python. So classes you can treat as a blueprint, and objects are the real world entity of that specific class. OOP makes code more organized, reusable and easy to think about because it works the same way we view real life objects. Again, in the next slide I am going to explain to you what does that mean here, class and objects, with some real world analogy, as well as I'll show you in the coding section also. Okay, so right now let me take an example of a car. Okay, you have a car. So if you think in real life, a car have two things. A car can have two things: properties and behaviors. So if I talk about properties, what kind of properties a car can have? It can have color, it can have speed, it can have brand, right? And what kind of behavior it can have? It can have start behavior, it can have a stop behavior, it can have accelerate behavior. So all these belong to one object, that is the car. So when we talk about a car, right, if you think class, as I said, class is a blueprint. What does it mean, a blueprint? Simple. Your plan, how your car will look like, what will be the shape of your car, what will features you will have. This all is kind of a blueprint that you have in your mind. You have planned that how you are going to build the car, right? But now this is the blueprint, this is the plan you have in your mind. But now when you are going to build that car, you are going to add all these properties, all this behavior in your car when you will be building that, right? So when you are done with the building of your car, so the car is now the object. Okay, so the car that you have built, now that is the object of a car class, right everyone? So same way in object oriented programming you do the same. Make a class car is the blueprint, and creating objects are the real cars that we drive on the road, right? These are the object of car class, right everyone? Great. Now let us go back to our Google Colab and let us do the coding, and there I am going to show you how object oriented programming looks like. Okay everyone? So right now I am in my Google Colab page, and let's get started with the coding section. So first I want to show you the basic difference between normal coding and object oriented programming. So if I think about normal coding, simple example guys, I have created one variable car color equals to red. Okay, so assume that you have a red car, okay, and the speed of the car is 0. So now if I want to create something, I mean some function here I am creating, that start the engine, print engine started, accelerate speed, and it is adding a speed plus 10. So it is adding speed plus 10. This is what it is returning right now. So if I call start engine, it will print, right, engine started. Then when I am calling car speed equals to accelerate, so in the accelerate I am passing the car speed. Okay, in the accelerate I am passing the car speed and I am just printing it. So the car speed was there 0, right? So now speed 0 plus 10, so car speed will be 0. See, this is getting printed. engine started and tail. This is normal coding, guys. Now what is the problem here? So here you can see these functions are separate. Okay, these functions are separate. They are not all together, right? If you focus, they are two independent functions that we have, and that is related to red color. Tomorrow if I want to do it for blue color, I have to again call them separately. Tomorrow if I need to do it for any other colored car, I have to call them separately, right? This is not right. Data is separate, hard to manage multiple cars. When we talk about multiple cars, it will be very hard to manage. Okay, this way if you follow the coding, right? But if I show you the OOP coding, again you don't have to understand, but just wanted to show you how it looks like. So as you can see, I have created a class car. Again I have created one blueprint where I have mentioned the start method or function. I have mentioned accelerate method or function. Then see, now you can create a blue car, you can create a red car, whatever you create, they all are under same class, that is car. That means if your car is a class, that means if you have your own blueprint, now you can easily use the methods like start, accelerate and everything. So you can use them and you can have your own methods. See, there are own methods, start, own method or own function, whatever you want to say, you can call it for now. So define start, define accelerate. So now this red car, this blue car, all can access the start, accelerate methods easily. So you don't have to use them separately. These all are connected into one class, right? So that is very easy to do, and that is what it means object oriented programming based coding. Okay, but you don't have to think much about it. We'll start from basics so that we can build our own class and objects. Okay everyone, great. Let's start with some components in OOPS. So first we talk about two important components that are there in OOPS, class and the object. So what is class and object? So class, as I have already mentioned, a class is a blueprint, design or recipe. It does not create anything by itself. It is only a plan. So when you are going to create a class, it's just a blueprint. On the above that I created a class, right everyone? That was only a blueprint. Okay, it does not create anything by itself. It is not creating anything by itself. It is just a plan. I'm just planning that okay, I will have this color, I will have this speed, then I will have this start method, I will have this accelerate method, right? This all I am planning, this is how it will be, but I haven't created any object from that class. I'm just planning that okay, how this is how my car class will be. I'm just planning for it, right everyone? But if I think about object, now an object is a real item created from the class blueprint. Now when you are going to create an object from the class, now that is an entity that is there in the real world and it is a real item that we can treat. Okay, but don't you think this class and object concept was already there, but we were not focusing on those? How come? So if I want to show you that, here you can see, let us create one variable contain string. So here I have created one variable var, then I have given my name here. Okay, so if I really print the type of my variable, okay, which is my name, can you see something is coming, class str? So you know, right, this is a string type data that I have kept in the var variable, correct? So this is a string type data, right? But if I am printing the type, can't you see it is a class str? So the str thing that we know, that is also a class only. Okay, this is what I have created. This is the object of the class string. The variable that I created, variable equals to Tanmay. So this is, or this var itself is an object of class str. Okay, I have mentioned here above we have created an object of str class. Likewise, as we know, in string, there are lot many methods provided by Python. Lower, upper methods are there. So str class is built in. It's built in Python already, that we have it, and it has its own behavior which we can define as in Python as a method or functions. Okay, so every class has its own behavior and own properties, like the card example that I've given last time, right? So string class will also have its own methods, own behavior. So what kind of methods it has? It has a lower method, it has upper method. Using that we can convert our string into lowercase and uppercase. Now this is a method only for string class, okay, as our var is a object of string class. That is why our var will be able to access methods of string class. Okay, if I create another thing, list, let's say now I'm creating one list 1 2 3 4. Again, if I want to print the type of list, can you see it's also coming list, class list? Why? Because this list is also class, okay, in Python. Again, it is a built-in thing that is there. So above we have created an object of list class. Again, list class is also a built-in thing in Python, and again it has its own behavior. We can define as in Python as method or functions. So again, list is a class. If it is a class, it will have its own methods. What kind of methods it has? It has append method, it has extend method. Using append, you can add a specific value at the end of your list. If you add extend, you can add a list of element at the end of your list. Okay, fine. So let me show you how you can create your own class. Now to create your own class, I'm going to just start writing here. So class coffee machine, I'm going to copy paste this class name coffee machine. Now I'm pasting my doc string. This doc string I'm copying and pasting from here. Okay, so this is a class. It's a simple coffee machine class. It makes coffee, it keeps track of water level and shows menu. So this is what it does. This is a coffee machine class that makes coffee and keeps track of water level and shows menu. That's what it does. Okay, so let me define my first constructor. Okay, so what is this constructor here? So this constructor is actually taking the input from the user. If I want to pass an input, okay, so right now I'm passing two inputs, the brand and the water level. These two inputs I'm going to pass to my class. Okay, so if I want to pass inputs to my class, what I need to do for that? I have to pass inside my constructor. Okay, if I do not have an input, I do not pass an input, but right now I have to pass it. These are two inputs. But what is this self? I will discuss later what is this self, but for now, like, keep it as it is, self. Okay, so now this brand value and this water level value I need to use somewhere, right? For sure I have to use them somewhere. Now to use them somewhere, I need to save them in some variable, right? So to save them in some variable, I'm creating a new variable, self dot brand equals to brand. Okay, and same I'll be doing for this water level. Okay, so now whatever brand value, whatever water level value we pass, this all will be saved inside this self dot brand and self dot water level. Okay, that's great. Okay, fine. Because why we are doing that? Because in our further logics and further methods, we are going to use these values. That is why. Okay, now let's see what is the next method, show menu. So let me just copy and paste and let me show you. Okay, let me just quickly set it up properly. Yeah, okay, fine. So I have created one function inside the class show menu. See guys, when you are creating any function inside your class, you call it as object, not object, sorry, you call it as method. Okay, by mistake I mentioned object. No, not object, method. Whenever you create something inside your class, I mean create any method, create any function, that we call it as method inside class. Okay, so I am creating one method, show menu. So show menu will take one input, self. Okay, but you can think it of self, be it self. I'll explain again what is self means, but yeah, show menu self. So whenever we are going to call this method, it will simply print these values: available drinks, espresso, americano, latte. It will simply print this and print this 30 dash 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 whatever. Okay, it will print all the values. This is what show menu will do. Okay, great. Now there is another method I have created, check water. So what check water will do? Simply it will check water level. See, I'm calling check water self. So checks current water quantity. So what it is doing is that it is simple printing current water level self water underscore level ml. So this self underscore self dot water underscore level is containing the water level value, right? If it is true, self dot water level equals to water level, this is containing the water level value. So when I'm calling check water method, I can check how much is my current water level. Okay, so I'm using this variable here, okay, in the check water. Okay, I'm done. Now let us use another method called add water. Okay, add water. If I call add water now, so when I call add water will take add water just a second, save here, changes. Okay, so when I call add water, so what add water will do? Add water will add some amount of water. That means I need input from the user, right? So that is why I'm passing an amount. How much amount I want to add, I have to mention that here, right? So that is why I'm saying self dot water plus equal to amount. So what I'm saying, you update the self dot water level value, add amount on top of it equals to, you can think it like this also, same. Just for your point, I'm doing that. Yeah, what I'm doing here, I'm updating the self dot water level value and I'm giving it like this. So I'm updating my self dot water level value. Okay, and then it will print that added this much amount of water and simple new water level. Using f string we can show that. Okay, my add water is done. Now there are three methods that I'm going to copy because they are same method, so that's why I'm going to copy them all together. Okay, and I'll explain what they do. Okay, fine. Yes, so this is my three methods: make americano, make latte, and I think I forgot to copy espresso. Sorry, I forgot to copy espresso, which I will paste here. Okay, fine, and I just do this. Yes, okay, fine. So there's espresso. Let me check if the indentation is not right. I have to do this. Yeah, now indentation is completely fine. Yeah, see, I have it is still there's an issue with this. Let me see. Okay, no issue. Okay, I have created make espresso, then make americano, make latte, right? So what this make espresso is doing, it is checking if the self dot water level is less than 50, it will print not enough water to make espresso. If self dot water level minus equals to 50, I mean it is checking if it is less than 50, then it will do not enough water to make espresso. But if it's not true, then what it will do, it will detect 50 from the water level. So that is what it is doing. It is detecting 50 from the water level and it is printing simple, your espresso is ready, this much water left. Okay, so when you call the make espresso method, it will do this. Same americano is doing, but americano is checking for 100 ml and latte is checking for 150 ml. As simple as that. Okay, so our class is ready. So now let's create object of our class, right? So how we can create object of our class? Simple, guys. Let me just copy paste them here and explain. I have created one variable machine and I am calling the coffee machine object, not object, coffee machine class. So my coffee machine class takes two inputs, Philips and 200. This two input it takes, right, everyone? So machine is the object of coffee machine class. So now if I comment all of them and if I try to call only this one, machine equals to coffee machine Philips 200, and if I then call machine the show menu, If I call machine the show menu, see it's showing me espresso 50 ml, americano 100 ml and latte 150 ml. It is printing this section, simple. And then it is printing this 30 dashes also. So now if I call check water, so right now my water level was 200, I have given as an input, right? So that is why when it do check water, see when it does check water, it's coming like current water level 200 ml. Why 200 ml it is coming? Simple guys, because this is what I have given as an input, that is why. Great. So now if I call make espresso, what will happen? If I call make espresso, it will come up like current water level 200 ml, your espresso is ready, and water left 150 ml. Why 150 ml? Because when I call make espresso, it is deducting 50 from the existing water level. I had given input 200, it has deducted 50, so now my water level value is 150 ml. Okay, that's what it is printing. Make latte. If I call make latte now, see, now it will come up like your latte is ready and your water level left 0 ml. Why? Because I gave 200 ml, it prepared espresso and deducted 50 ml, you had 150 ml left. Now to build latte, to prepare latte, you need 150 ml. When it deducted 150 from 150, I got 0 ml. Because I got 0 ml, now if I want to call this method americano, if I now call the method americano, okay, I mean let's call it americano, that machine. If I call this make americano, so it is saying not enough water to make americano. Why? Because americano needs minimum 100 of water, 100 ml of water, right? But it is not there. So what I do, I will call add water and add 100 ml. I'm adding add water, and now if I add it, see, it's showing new water level is 100 ml. So now if I call americano here, the below, and if I execute, see, I'm executing this. Like I added add water 100 here, and then I'm calling make americano. Okay, so it should be able to show us the output. Okay, yeah, so we are able to get the output. See, now it's showing like your americano is ready and your water level is 0 ml. Why? Because I added 0 ml and americano needs 0 ml. Sorry, I added 100 ml and americano needs 100 ml to prepare the americano thing, right? So that is why now water left is 0 ml. So this is the first class that we had created together, guys, using OOPS, and I hope you have enjoyed that. Okay, we are good so far. So let us now continue with our next topic, that is encapsulation. Okay, what is encapsulation? So encapsulation nothing but encapsulating something. What does it mean by encapsulating something? That means hiding something. So it means hiding the internal data of an object and allowing access only through safe methods. It protects the object's data from being changed in the wrong way. So if you think, if I go back to the class that we created before, you can see this brand value, water level value, right? These are the data of our class, right? Even these methods and everything, these all are data of our class, correct? So if it's a data of our class, so we need to protect those data, because if any chance our user is trying to change our data, and if they're able to do that, our code may fail, right? So that is why we do not want that user is able to change our data, class data. So that is why encapsulation is there in the picture. So now before continuing with encapsulation, there's something I forgot to explain, that is the self. What is the self thing? So guys, can you focus on something? When I am calling machine, coffee machine, and when I am calling show menu, I am not providing anything in the input, right? But in the show menu, I kept self here, but I am not providing any input here. What is happening? It means when you call the object, dot show menu or the any method of the specific class, by default this self is actually containing this object as an input for all the methods that is defined here. That is why we are passing self here. So self for every methods, for every variable. Why I have defined self? Because this self is representing the object of the class that I will be creating, but or in this scenario that I have created now, right? Because of this situation it is trying to show you all the self here. But now the thing is, self is not mandated. I mean, it's not that you have to use self everywhere. No, nothing like that. You do not need to use self. It is a naming convention that we all follow. You can follow the naming convention. If you want to give any other name instead of self, you are good to use it. But this is a convention that people follow, and if you search code online you will find mostly people are writing code using this method. But again, that is up to you, but I just wanted to let you know what is this self mean. Okay, chalo, that's great. So if we go next now, and if I think about the encapsulation thing that we were discussing, so as I've already mentioned what is encapsulation and all. So why do we need encapsulation? Simple, guys. To protect important data. We do not want anyone to change values directly. If we do not hide our data, anyone can change our data directly. I will show you how they can do that in the next. Now another one is to prevent mistakes. Data should be updated only through the proper rules. If we follow a proper rule to update our values, we do not do mistakes, right? We can prevent mistakes, right? So that is why we should follow some rules, so that the way we can update our update our data. Okay, the next one is to keep code clean and organized. Now object controls its own data, no chaos. So if you follow this method, you can control its own data. I mean, the objects that we will be creating, that will control its own data, so chaos won't happen. Now next is to hide unnecessary details. See, in our code there will be few things that we are not interested. I mean, we as a user are not interested, right? As a developer I might be interested, but not as an user. As an user I just need to see those values which I need to use in my case, right? Likewise, user should only see what is needed to use the object. That means we can hide the unnecessary data that is not required for the users, so that data can be safe, to make big programs easier to maintain. If internal logic changes, outside code doesn't break. So if you are writing a very big program, if you follow encapsulation, it can hide the internal logic so that your code won't fail. Okay, so these are some of the reasons why we need encapsulation. So now if I come up with the coding example, first we'll try to go ahead with some example with private variables. What kind of private variables that we'll be talking about? So right now, if you recall, I have created, last time also I've showed you, but this is a new class that I am creating, class student. So this student takes two input, the name of the students and the marks of the students. So I'm creating self.name equals to name, like I did before. This method, this way, when you create any variable inside a class or inside a constructor, we call it as public variable. That means this variable can be accessed by any object directly. Any object can access this variable directly. There's another method called private variable. How it is private? When you give any to underscore before any variable name, this is treated as private variable. So I am saving the marks value inside self.__ marks private variable. Okay. Now I have created one method called get marks. Okay. What I am saying, as I have said that, okay, this marks you can not access it directly, but what if you want to see that value? If you want to see that value, as I have mentioned already on the top, that to prevent mistakes, data should not be updated data should be updated only through proper rules. So I have created another method. This method will help you to see the value. So I'm giving you a method. Using that method you can see the value. You cannot directly see it, but I'm giving you a method to see it. So I'm following a proper rule to see the value, so that my code won't get broken, right? Okay. So now what is happening? So I have created one variable s equals to student Rahul 85. I am calling print.s name, guys. See, s name, and I just execute this code. See, when I am calling s name, I am able to execute Rahul. S is the object of student class. So when I am calling this name, which is coming from here, okay, which is coming from here, I am able to access it from a class, sorry, from an object, right? So, and when I call s.getMarks, so getMarks is giving me the marks value that I have provided 85. But if I do s.name equals to, let's say my name I give, okay, and if I execute, okay, see the code ran successfully. And now if I want to print my name, see, it's printing Tanmay now. So in the class, that when I created the object of the class, I have provided the student name Rahul. But when I am calling this student name Rahul, I am calling, right? And when I am calling this one student name Rahul, and when I am updating here s.name, when I'm updating the s.name value, it's now Tanmay. So see, you as a user is able to change the value, you are able to change the data, but that is not correct, right? Your logic depends on the input, how you give. So if your input is wrong, if you are able to change the input, your code will fail for sure. But you do not want that to happen, right? So if you want that it won't happen, what you need to do? That's why I did underscore marks. So what I did now, I have kept marks value as a private variable. So if I try to execute like the same way, if I try to execute the marks, see, I won't be able to access it. It's saying like attribute error, student object has no attribute underscore marks. I cannot access directly any private variable. There's a way how we can access it, but at least directly we cannot access it. Okay, but at least directly we cannot access it. So that is why it is a private variable. Even if the user wants, they cannot access it, so they cannot change it also. Okay. Now there's another method left, set marks. What the set marks is doing, as I have already mentioned, that I cannot update the set marks value, right? I cannot update the set marks value directly, but I can update it through some process that I have put it in here, set marks. So in the set marks, see, it takes input m is marks. See, if I intentionally give a negative number, my code is written in such a way that it won't actually update. It will show you like marks cannot be negative, but it won't update it. But if I give a correct positive number, it will update the value, self.marks equals to m. So if I call s.setMarks, okay, set marks, and if I give 56 and if I execute, see, and now if I want to get the marks again, see, the marks is now 56. So I am able to update my private variable value also, but through some method, through some rule, so that user cannot put any invalid value or any irrelevant value. I can put a proper checkup while calling those kind of methods. So I have the full authority on my code that I know even if user will try to add some wrong value or irrelevant value, my code is logically there who will take care of it. So this is the way how you can create your private variables, how you can access it, and how you can change it. So this is the example of private variable. So same example below I have showed for private methods. Same example, guys, same example, same. But what is happening now? See, I have created one class calculator. I am passing pass. What means pass? Because my class is not taking anything as an input, so that's why I am pressing pass. Good. Okay. Now I am creating one method, private method, that is called underscore log. So log is the method name, and when you give underscore, this is now a private method. Okay. Again, it takes two input, action and the value, and self is the object when we create it. So action and value are the inputs for the log thing, right? So when I am calling def add self a comma b, when I am calling this def add self a comma b, what is happening now? This is a method, simple method. This is a simple method, public method, add self a comma b. So what it is doing, simple guys, it is trying to take input in the result variable. I am adding them, say result equal to a plus b. So this result is containing the a plus b or added value of them. Okay, now when I am calling self dot underscore underscore log, self dot underscore underscore log, when I am calling, see why I am calling self underscore underscore log like this. In my add code or add method, this self dot underscore underscore log I am calling because I need it, right? But if you focus, this underscore underscore log is the method of my class only. So whenever you want to call any method in your class which is already there in your class, you have to call it like this, self dot underscore underscore log, then add result. So this takes two input, action and the value. Action is add and value is result. So this self log I am calling it from here, and then I am returning the result. See, I have created one variable c equals to calculator. Then I am doing c dot add. When I am doing c dot add, c is showing log add 8. So this is calling this line also, and this line is calling this line. So that is how we are able to get log add 8 8. Okay, so this c add returning me the result. So that is why when I am printing, I am getting 8 as an output. Okay, that's great. So now let us see some example of our own custom class again, school system custom class with the encapsulation. Okay, so again I am creating a class school system, and what this class is doing, this is a real world encapsulation example. It has student marks, fees and attendance are private. So in this school system class, I have three variables. They are private. Marks, fees, attendance, they all are private, and only safe methods can update the data. So only safe method can update the data. Okay, so what I am doing here, I am creating one again constructor. What this constructor is doing, self, name and roll number. So this constructor or this class is taking two inputs, the name and the roll number. Okay, the name and the roll number. Okay, so again likewise same, this name and roll number I have stored them as a private variable, and this marks, attendance, fees paid, this all are default values are 0, and they all are private variables because I have given underscore underscore here. But they are not coming as an input guys, right? They are not coming as an input, but we are putting some other values for our own logic. So by default I have created three values, marks, attendance, fees paid. They all are having 0 values for now by default, and they all are private variables. Okay, great. Okay, now I'm creating another method called show details. So show details will print all the details, name, roll number, marks, attendance, fees paid and everything. Now there's another method called add marks. So what add marks does, add marks will take m, add marks will take the marks that I want to add. So in the m will contain the added marks. So now I'm checking if the marks is less than 0, it will print marks cannot be negative. If it is not, it will update the marks value. See, marks value is a private variable. I cannot directly update it, but through the methods I can update it. So this self underscore underscore updates values by default 0. When I am calling the self underscore underscore method plus equal to m, so this self underscore underscore method is having value 0 plus the marks value. So plus the marks value when I did, so I got the marks added message. Okay, when I am calling marks edit. Okay, good. Same for marks attendance, I am updating this attendance value. Same for pay fees, I am updating this pay fees value. And using get marks, you can get the value, you can get attendance, you can get the attendance, you can get paid. You can call that variable private variable that will have the output. Okay, so see what I am doing here. If I just show you directly, student equals to school system. I have defined one class here which contains two input, name, name and roll number. So the name is Amit, roll number is 15. Now I am calling student the show details, and if I execute this code, see it is printing, right? Name Amit, roll number 15, marks 0, attendance 0, fees paid 0. Why 0? Because it's not yet initialized anything, it's just by taking default values. If I do add marks 25 now, and if I again do show details, see when I did add marks 25, it will print that 25 marks added. Like here we have given mark added and it is updated the marks value. So when I call show details next, see now in the show details section marks value is 25, but it was 0 before because by default value was 0. Now I updated the value by calling the add marks, right? So now I call the mark attendance, pay fees, show details. If I now show the details, you can see when I call them the attendance mark, printing is coming, 2000 fees added is coming, and now see now your data marks 25, attendance 1 days, fees paid 2000. Okay, fees paid 2000. Okay, I think we are good with this encapsulation section also. Great. Now let me talk about inheritance. So inheritance means one class, child class, can use the property and methods of another class, the parent class. Simple, it is like in child inheriting traits from parents. So the parent class is also called as base class or super class, and the child class is also called as derived class or subclass. So inheritance is nothing but there is a concept of inheritance, which means we can copy or we can use one class property and methods into another class. Okay, so let's see in the example. So there are lot many types of inheritance are there. We'll be talking about them one by one. So the first one is single inheritance example. So in the single inheritance what I am doing? Nothing. I am creating one class animal. Okay, and see there is no constructor. See guys, giving constructor is not mandatory. If you want, you cannot have constructor also. If you want, you can have constructor. Giving constructor is not mandatory. Like I haven't given any constructor here because it is not required here. If it is required, if you give, that's completely fine. If there is no requirement, please do not give it. Okay, that's great. Now let's talk about it. Single inheritance example. Parent class. Okay, I am creating a class animal. It is a method called eat. And self, as I've already mentioned, it is the object when we create it, and simply it is printing I can eat. Simple. Now there's another class, child class, class dog. But now when I calling dog class, inside the dog class I am calling their class that are defined animal. So this is a parent class. I am treating this as a parent class. That means I can use its properties and methods in my class. Like right now I have a child class called dog, which is inheriting from animal class. How we got it that it is inheriting? It is inheriting because I am passing the animal here inside this dog class. Then I am calling a method called bark. I can bark. See now the magic. I have created one variable d. I mean the object of dog class. See when I am calling d.eat, see it is printing that I can eat. But the eat method is not defined here, right? But it is defined in the parent class, right? And that is why it is inherited from animal. So that is why even though I am calling it from the dog class object, it is still able to access it that I can beat. And the bark is already there in the inside the method as a inside dog as a method. So that is why I am able to see I can bark. So it is able to bark it. Okay. So this is a one example of single inheritance example. There is a multi-level inheritance example. Okay, you can have multiple levels of inheritance. What kind of levels? So this is the top class, or you can say grandparent class. Okay, you can treat this class as a grandparent class, living being, and it can breathe, and it is printing breathing. I have created another class animal. Animal is inheriting living being. Okay, that means this animal can access breathe method also, right? As well as it can method its own variable eat also. This is another method another class I am creating, dog. Again it is now inheriting animal. That means dog can access eat also, dog can access its own method bark also, but dog can access breathe also. Why? Because living being is animal inheriting living being. That means animal does have the capabilities of living being as well as animal. Now when I'm inheriting animal, when dog is inheriting animal, that means it has the access of the eat method of animal as well as the breathe method of living being as well as its own method access. So that is why when I've defined d equals to dog and when I'm called d dot breathe, d dot eat, d dot bark, d see outputs are coming breathing, eating, barking. Why? Because this breathing is coming from this. So this is a multi-level hierarchical multi-level inheritance example. Okay, so let's talk about multiple inheritance. So what happens when we talk about multiple inheritance? Simple, guys. There's a Python class I have defined father, and father has some skills. There's a method called skills for father. There's a class mother, and mother has also some skills. Mother cooking skills, father driving skills. So if I want to pass multiple inheritance, I can do that. Python allows a class to inherit from multiple classes. So I have created two classes and I have inherited them like this. That we call multiple inheritance because we have called multiple classes. And this class, child class, also has a method called extra. It's like child dancing. So now if I'm inheriting father and mother, that means I have the access of skills method. But there's a doubt, right? Because I have same methods for both of the classes. Then how my child class object will understand that which one we are talking about? So when I'm defining one object of child class and when I'm trying to call c.skills, it is checking first father, for father then mother. So first it will check for father class, is there any skill method available? If yes, it will show that. Like why is it is showing here father driving? Why? Because father name came first, I mean father class name came first, so it is checking that is there any method available skills inside father, which is yes. So that is why it is printing father driving. Okay, but if there won't be no other classes named skills, then you will definitely try to execute the mother classes skills variable. But right now it's not using that. It is trying to focus on father because father already have the same method and it can execute that. Okay, so this is the example of multiple inheritance. This another one is hierarchical inheritance. So what happens in hierarchical inheritance? See, I have created one variable, not variable, created one class shape, and it has a method area self, and it is printing area formula. Okay, great. Now I have two classes, circle and square. Circle and square both inherited shape, right? So that is why now I have created one circle object from circle class, square object from square class, and both of them can call area method from shape, which is the inherited class of their object. Okay, so if I execute this code, see it's able to print area formula. So this we call it as a hierarchical inheritance. So the last one is hybrid inheritance. So hybrid inheritance is nothing but where it's simple, guys, where we have different like mixed kind of inheritance. Here you can see I have created a class here, right? After creating a class, I am simply here doing simple inheritance, right? Now this is also another inheritance and this is another inheritance. So when you have a multi-level inheritance, yeah, a multiple inheritance all together, right? Because this is a multiple inheritance example. These two are, this section is like multi-level inheritance example, right? So you can have this kind of different kind of inheritance that you want to define. Okay, that's great. Now let's talk about something super. What is super? So super is used to call the parents class methods from the child class. Okay, so super is used to call the parents class methods from the child class. In simple words, super means go to the parent and run its method also. So let's see in practical example so we get it. Here I have defined one class parent. Okay, I have defined one class parent, and then I am defining one method, define show. So when I call define show, it's printing that this is the parent method. Okay, it is simply printing that this is the parent method. Now the next is a class child. Okay, class child. So now I'm calling class child parent. When I call class child parent, what is going on is I am calling class child parent. Okay, So that means this child class is inheriting parent, right? Okay, that's great. It's inheriting parent, that's great. Then I am calling another method, show method, right? Again, same method name inside my child class. But what if I want to execute the parents show method also while executing my own show method? That's the super comes in. So using super, you can call, already mentioned, you can call parents class methods. So parent is my parent class because child is inheriting parent class. So now I'm calling super dot show. So when I'm calling super dot show, what it is doing is that simple, guys. It is trying to super dot show. It is trying to call this show method from the parents class. Okay, and simple, it is printing now this is child method. So now I have created one object of child class and I am calling c.show. See, when I am calling c.show, see, it is first printing this is the parent method. Why? Because this super.show is actually having this is the parent method. Then it is printing this is the child method. So this is a super works. Okay. Okay. So there's another thing. There's another method I have created here, class animal. Okay. Not method, sorry, another class I have created, class animal. Define underscore init self name. It takes name as an input and the self name is containing the self. And I have defined two methods here, make sound and sleep. It's simple printing that makes a sound, then simply means sleeping. Good. Normal class that I have defined here. Now there's another class dog which is inheriting animal now. Okay. And I am now defining my constructor where name and breed, these two inputs I am taking from dog class. But what I actually want that so what I actually want, I want to call this name, because see, name is there for both the classes. Name is there for dog class, name is there for animal class. For both of the classes I have dog, right? So for both of the classes I have dog, that's true. So if I have dog for both of the classes and the name is there for both of the classes, if you see for dog, for animal, name is there for both of the classes. So that is why I am calling super.init name. So I am telling you call the parents constructor, not my own constructor. I am saying you call for the name, you call this parents constructor, and for breed you take mine. So you take mine breed, no problem in that. Then you print like bark, simple bark. There's a method called bark and it's simply printing self.name barks oof oof. Okay, simple. Okay, so I have created a class of dog, created object of dog class D. I am calling dog buddy and golden retriever. Okay, that means I have provided the name and the breed. Okay, and when I call d.make sound, it is inheriting from animal, because obviously I am inheriting from animal. Make sound is not there for dog class, right? But it is there for animal class. So that is why when I am doing d.make sound, it is able to call this. See, it is able to call this. When I do make sound, it is able to call makes a sound. See, buddy makes a sound. See, why? Because when I'm calling this method that is there, when I'm calling this method make sound, which is there inside my animal class, now when I'm passing my name here inside the dog class, and I have mentioned here super init name, so it is calling the parent construct. So that means when I am passing this input inside the class, automatically this name value for this animal class is buddy, because I am calling this super. So super is giving the information that okay, the name that is there that I will be passing, you take it here, you send it here. So that is when I am calling a method from the parents class also, it is still able to take buddy into consideration, because buddy is there in the dog class, but I have called super to call the parent constructor. when I give the name of the dog. Okay, now next sleep is also there only. See, it is only able to ping buddy is sleeping. Then for dog class, it has own bark method. So bark is simple, it is able to call that, okay, buddy barks, oof oof. So this is the whole and sole example of inheritance that I have taught you folks. Okay, chalo. So let me just show you another very basic example of again school system with some inheritance added. Okay, so I have created one parent class. Now this is my parent class. Okay, so what is the parent class? Class person. So this parent class takes two input, the name of the person and the age of the person, and simple show basic info. If you call it, you can see the details like this. Now I have created a function called student, not function, created a class called student. Now this student is inheriting this person class. Okay, great. It is inheriting the person class, fine. So now what is happening? I am doing define underscore init underscore. Okay, underscore init underscore. Great. So it takes few inputs: self, name, age, roll number, grade. So it takes this input: name, age, roll number, grade. But now, as I'm inheriting a person in my class, so this name and age are already there in my person class, right? So I no need to think about those. So that is why I'm calling parent class constructor. I'm telling you send this name and age here for this person class. Okay, so now this super is calling the parent class constructor here. Okay, for name and age, because they are same for person and the child, but for roll number and grade I have simply created that. Okay, fine. So now next, show student info. So when I am calling show student info, what is happening here? Again, show student info is a method inside student class. I have another method called show basic info inside parent class. So what I am doing here, I am calling that method. I am calling my parents class method. Okay, I am calling the parents class method here, and then I am printing the values. Okay, now there's another child class, that is teacher. Teacher is also inheriting person class only, and it takes three inputs: name, age, and subject. As I have already mentioned, name and age is already there. It's already there in the person class. So that is why I am just doing super, and I am just taking that input for person, and for the subject I am saving them for subject. Now I am creating another method called show teacher info. Again, this teacher info, inside the teacher info I am again calling the super, and again I am calling the parent class method show basic info. Then I am printing my own info. Okay, that's great. So now what will happen? Let's see. So in the student section I am passing student Amit 15, 23, 9th, and teacher Reena 30, mathematics. When I am calling the student class method show student info, see it is showing. If I execute, see it is showing for person info, name Amit, age 15, roll number 23, grade 9th, right? So it is updated. It has taken that name and age in the person class. Okay, and it has printed accordingly, as well as it has printed for both of them. I mean for person info, and when I did t dot show teacher info, when I did t the show teacher info, see it has printed the subject also, subject mathematics, and this was the student info where it has printed grade 9th, because till this is my person info, and these are the two student info, and till this is my person info, and this is my student info. Not student info, sorry, a teacher info that I called, right? So this is how you can build your own school system, again custom class. I have showed you with the inheritance example. Okay, that's great. I think we are good with the inheritance section also. Now let's talk about the section called polymorphism. Guys, polymorphism nothing but it means one thing, many forms. A single function or a single method name behaves differently depending on the object that uses it. Like, let's see, I have created a class dog, and it is a method called speak, and it can do oof oof. I have created another class called cat. It has the same method speak. It can do meow meow. And I have another method called animal sound, and I have taken animal as an input. Now this is a function, guys. This is not a class inside class anymore. This is a normal function. So I am created a function define animal sound, and inside animal sound I am providing animal, and it will call the method called animal to speak. Now I have created two instances of two object of class, for dog class and for cat class, D and C, right? So D is containing all the methods of dog class, C is containing all the methods of cat class. So when I am passing animal sound inside this animal, so this D has its own speak method which will do oof oof, and cat will have its own speak method which will do mew mew, right? So when I am calling this C, it's now calling oof oof and mew mew. Why? Because dog has its own speak method, cat has its own speak method, okay? But they are same in terms of definition, but they are doing different things. Now based on the different inputs, they are doing different things. That's why we call it as polymorphism. There is another thing called method overriding. What is method overriding? See, there is a method I called class animal, okay? Same method, not method, sorry, same class I have defined, class animal, and it has a method called define speak, and it can speak like print animal makes sound. Now I am calling dog, I am preparing dog class. It is inheriting name, it is inheriting animal class, but it has the same method, see, speak, but output is different, print dog barks. So what will happen now? Because it has same method, and but dog is overriding animal. But what is going on there? See, when I am creating a class, not class, I am creating an object of dog class, D equals to dog, and then I am doing D dot speak. This now method overriding is happening. How come overriding is happening? See, dog is inheriting animal, right? That means dog has all the characteristics of animal class. That means all the methods access dog has. But as dog already has a speak method, it is overriding the speak method of animal. Because when I am doing d.speak, my system first will check, is there any speak method available inside my own class? Yes, it is available. That's why it is printing dog barks. But if this speak won't be there, then it will check that okay, I am inheriting animal class, let me check if that same method is there in the animal class or not. If yes, it will execute that. But right now I have speak in my class itself, so that is why it is overridden the animal class method. Okay, so when I pinged d.barks, it has did the bark. Okay, there's another thing called method overloading, guys. Okay, but just for the information, method overloading cannot happen inside Python. Python doesn't support method overloading. It doesn't support method overloading. So how we can work on that? Simple, guys, no need to worry about it. Simple, what you can do, you can call class calculator. There's a jugaad overloading I'm showing you. I have created a calculator, class calculator, and takes input like add, function add or a method add, and takes three inputs A, B, C. So what does it mean by overloading? Overloading means whatever inputs I will give, right? Whatever inputs I will give, based on my inputs, it will change its behavior. Okay, it will automatically set it by itself when I do method overloading. Okay, because you see, I have created, but it's a jugaad overloading. Okay, so what I am doing here, see, I am calling A, B and C. So I am keeping B and C value 0 by default. So whenever user is calling, see, I have created a calculator class object here. When I am calling add only with one variable, I will be getting output only 5. Why 5? Because 5 is there, but other values are 0, 0. When I am giving calculator dot at 5, 10, it is printing 15. Why? Because 5 plus 10, 15, but C value is still 0. And then when I am giving 5, 10, 20, it is giving me the 35 output, because they're adding them. So what is method overloading is doing, based on the input, it is dynamically able to handle things, right? So it's overloading the whole process. So that is why overloading is not possible in Python, but it is a jugaad that you can try to do method overloading in Python. Okay. So let's talk about the last thing, that is regarding Dunder methods. So Dunder methods are special functions in Python whose names start and end with double underscores. Python uses them automatically in the background to make your class behave like built-in types. Okay. Dunder means double underscore, we call it as Dunder. Like we used to give init, right? If you focus, if I go back here, this underscore init underscore, this is also a Dunder method. This we call it as a Dunder method because they have underscore there. Okay. So let's see some Dunder methods here. See, Dunder method, Python uses them to automatically in the background to make your class behave like its built-in types. Okay. So I have created one class student. It's taking input name and score. Then I'm doing underscore str. What this underscore str does is, when you try to call print, when you create an object of the class and when you want to print something, it will actually call the underscore str method behind the scene. Here I have created one variable s and it is calling student Amit 90. This is my class object. Now when I'm doing this print s, behind the scene it is actually calling this underscore str. So when I'm printing s, it is showing student name Amit score 90. See, the way I have written same, it is showing up. So this is the Dunder method. Okay, this is the Dunder method. Okay, fine. This is the Dunder method that is showing up student name Amit score 90. Okay, this is what is happening. This is another method we talk about, that is add. So I have created one class score and it takes input underscore init. It takes one value as an input value and this is saving it here. Then I have to call a method. There's a method called add, and add takes one input as other, and then it is returning this score by adding self.value plus other.value. Okay, so what is happening here? That means I'm trying to call self.value. That means when someone, okay, let me tell you. When I am calling this add underscore add, I am calling this score again, this score class again. So I am taking this also, which is my value already that I have given as an input, as well as the others value, because this other will also be the class of score only. Okay, this other will also be the class of score only. When I will show you, you will get it. This other will be the class of score only. If it is a class of score, okay, that means it will have a object, and that object will have a variable called value. So that is why I did other dot value. So see, I have created one s1 here, one s1 object of score, where I have given input as a 10. So now value is 10 here. s2, I have given score value 20 here. Okay, so when I am calling s1 plus s2, what it is doing is that when I am doing this s1 plus s2, it is actually calling this underscore add. Okay, when it is calling this underscore add, and this self.value is actually coming from here. Okay, and this order.value is actually coming from here. Okay, so what is happening is that it is trying, because for this both of the classes, this self is the object, right? This self, as I have already mentioned, is the object. This is already my object because I'm calling this s1 and s2. So they both belongs to score class only. So when I'm doing this s1 plus s2, it is seeing that, okay, I am passing self. It is first of all calling this method. It is saying, okay, this is self. Self means my object, and other. What is the other thing? This s2. h2 का value 20. So 20, again this is a score class and it has the input value, so that is why it is doing other dot value. So other is the score class actually, and we can access this to dot value because dot value is containing the value, right? When I am doing this addition, this is how the output is showing up, like 30. Okay, so there's the last method that I want to show you. I think last 2-3 methods are there. Yeah, underscore eq. This takes equality. Simple, it takes equality. Are they same or not? Same. I have defined one box class. It has a input size. See, I have defined 3 box objects. Okay, 10, 10, 15. Okay, so when it is calling b1 equals to b2, b1 and b2 both are box class objects, right? So when I am calling b1 equal to b2, it's actually calling this method, and for this method, this self is actually getting the b1 and this b2 is nothing but this one. So this b2 is also a part of box, this b1 is also a part of box. That means they both have size variable access. So that is why I'm doing self.size equals to other size. I'm able to get the value true and false. Same for b1 and b3. Same for b1 and b3. Okay, so the last method that I want to talk about, that is class notebook I have created, and I'm again input taking from the user and the pages I'm pulling in. Okay, so now I have a Dunder method called get item. So I'm assuming that the notebook will take a list as an input. Okay, see here I have processed a list here as an input. So when you pass a list as an input, and when you want to access them, like you want to make it behave like list indexing, if you want to do that kind of a scenarios, so you definitely should see return self.pages index. Okay, when I call self.pages index, so index is the index that I'll pass, like I pass n and the third bracket I pass 1. So when I'm calling it and when I'm putting it, see I'm getting science. Why? Because self.pages is actually a list, right? And this is how we do the indexing, we all know it. So same is happening here, but when this n1 is calling, right, it is this method, or when I am printing this, it is actually calling this get item, and based on that it is showing the output. Okay, so this is the Dunder method. So yes guys, this is all I had for today. I hope you have understood it. If you have any doubts, any feedback, any suggestions, feel free to share in the chat, and I will share the notebook link in the description box so that you can easily use it. And there are few topics are still left, static method and class methods. Those I haven't explained here in this video, but there will be another video where I will be explaining that topic, and then we can proceed ahead with our MLOps playlist. Okay, then thank you everyone for watching this video. I will see you next time.